Okay, so now we can kind of get jumping into our stuff. The next thing on our list has to do with files, reading and writing files. And we looked at that a little very briefly earlier because some people will need that. And then this is one that I want to take it a little bit further than that minimum reading and writing files to save the data for a particular piece of software. Because a lot of the people on the roster here are doing server administration or networking infrastructure or cybersecurity. I think half the class was cybersecurity. So you'll approach files a little bit differently than, say, just the people developing a piece of software that need to save the data that goes with that file. So I wanted to make sure and look at that in Python because, well, it'll be more useful for you. And obviously the people developing particular pieces of software will also need that. That's why we have access to it in Python. But kind of look at files in the way that you're going to need them and start down the path that you're going on instead of covering a bunch of things about Python that are just like a little bit to the left of what you're actually going to need for cybersecurity or server administration. So one thing about this is we'll need access to our file structures and stuff. So we will, if you want to follow along in class, you'll need to have Python installed on your local machine. Some of you may have already done that. If not, that seems like a good starting point.
Spider works for that, right?
Let's start with looking and getting installed. What's that, Tyler?
Spider works for that, right? I have that
Yes.
installed in the Windows VM.
Spider,
okay, sweet.
Yes, Spider brings its own one. I was just going to do a basic installation.
Okay. I just liked the way it looked when you showed it. So I was like, okay, that's cool.
Oh, yes. Spider is definitely my favorite IDE. IDE is where we develop our programs. It stands for Integrated Development Environment, which is really a really fancy text editor, place to write the Python code. That has some other features, usually a run button and stuff like that. Color coding, so underline things in red when it doesn't match the Python language, just like Microsoft Word does for the English language. When things don't match the English language, it underlines it in red, and have that sort of stuff for the programming language. There's a simple one that comes with a regular installation of Python. So to install it, if you just search for download Python is what I usually do. And right at the top of the search results, you should see this page, python.org. The latest version is 3.10.4. You'll just choose the right version, and the website should look at your system and determine whether you're on a Windows machine or a Mac machine or a Linux. Is anybody using a Chromebook? There's one extra step to get it installed in a Chromebook, but basically you'll just download the installer. The website should be able to tell what system you're on, but it doesn't hurt to actually go ahead and click the particular button just to make sure you're getting the right one, and then run that installer. And you'll want to do that. I'll share the steps for doing that, and then I'll get it installed, and then we'll be back over here. So if you all want to start doing that, so you can follow along in lecture, I'll log into my Chromebook. I already had it brought in and show you the extra little step that needs done. That might need done for your Chromebook. On my Chromebook, it was there by default. Let's see, I have to find Zoom on here. So I'll just join the meeting. Oh, I can find the numbers. And that'll give everybody a moment to get that installed if you want to follow along with the lecture. 1.3 is, there's a slight subtlety. I'm going to draw some pictures on the board just very quickly. Oh, don't need the video here. Okay, is there feedback? Okay. My Chromebook always insists on turning that on by default. it turns the mic on by default. So when I log onto a Zoom call, it automatically starts feeding back real quick. So all of Google's stuff, the Chrome OS, Android OS, those are all Linux systems. So if you want to install Python to work with, it is much better to go ahead and install it on the Linux system, which the little Linux desktop on your Chromebook. If we go to settings, if that's not turned on, which at some point last year, they started turning it on by default. But if anybody's using a Chromebook and it's not turned on, if you go to settings and under advanced, and this option for developers, there's this option here for the Linux development environment. And you can just, well, if it's not turned on yet, it'll be the little switch button that you click and turn it on or off. And then you'll have some other options, but there's a little menu that you walk through and set up how much space does it get? Because it's basically a virtual machine running on your Chromebook. So it gives you a little virtual desktop, and then you can install everything there. Well, I have a Linux system here, and when you install it on Linux and Mac, they were Python was used when they were built. So when you ask for one, make sure you put in Python 3 after you install the latest one, because the Unix kernel back in the background operating system stuff itself, some of that was built with Python 2, and they haven't really updated it yet. It's a little bit past time. So if you just type Python in your terminal or on a Linux or a Mac, you'll get Python 2, which is about 15 years out of date. So make sure you type Python 3 if you're on a Mac or a Linux system. And if you're on a Chromebook, and if that's not on by default, just go to settings, and under accessibility, oh, whoops, not accessibility, under developers, there's a little Linux desktop, virtual Linux desktop. They call it Crostini. But it's a virtual machine because we can't actually run virtual machines on a Chromebook. One of the Chrome operating system is actually more like a network than a single device. So there's lots and lots of virtual machines running. So the internal security on the device is kind of set up to block other virtual machines, because it knows about all the virtual machines it created to build the network that's there. Trying not to get too detailed into the description here. So a really good security measure is to not allow virtual machines to be on there. So to set up our own virtual machine, we have to go in there and deactivate that thing that all of the security on the device is built around, which probably immediately sounds like a really bad idea and something we shouldn't do. So they added this little virtual desktop that we can use and actually access the Linux system on those, which is better than running Python directly on the Chrome OS. There are some advantages, some big advantages to that. So you want to do that. But basically, for following along the latter part of today's lecture, you'll want to have Python installed on there, and we'll look at the idle IDE. That's what comes in with the installer. So first off, some notes about writing about files. And really, this is a small distinction that only matters about half the time. Half the time it matters, half the time it doesn't. We can ignore this distinction and just treat things, treat two different things as equivalent. And I guess textbook editors and tutorials and things like that, they went with the just ignoring the distinction, even though it's about a 50-50 split. For server admin people and cybersecurity people, that distinction is going to be very important. So that's what I wanted to cover. So the main thing on our to-do list to learn is reading and writing files, which that's the distinction. So instead of reading and writing file, I'm going to extend that a little bit further and say read, write data to or from a file. And then the other thing, the distinction that's going to go further is manipulating the actual file. So with our lesson, when we're going to do here, which our normal terminology we would use for it is persistent data. We want our data to stick around between runs of the software, not just for any particular run. That way we don't have to get all the same inputs again next time we run the program. So persistent data, we need stuff to stick around. That's our main thing, but there's a slight distinction. And for an analogy, I like to use this old picture because it's easy to visualize. It's something y'all have probably seen in textbooks or history books or something. But have y'all at least seen the pictures of the old reel-to-reel tape machines? Back when we stored data on great big reels of tape. Just like the audio tape, probably before you all were born. It's 2 pieces of Scotch tape with little iron filings in between. And then those iron filings, well, they're iron, so we can run them past a magnet and sort of change the polarity of those iron filings between 2 pieces of Scotch tape. Then we have a great big long, and then that gives us a binary state to store all the data. We talked about the 1s and 0s for binary, and with magnetics, it's going to be north and south pole, or instead of 1 and 0, N and S, but that's still a way to store our binary data like we talked about. And back in the 50s, they invented the audio tape where we have just all that iron filings and on 2 big reels. Hopefully everybody's at least seen old pictures of that. It's easier to visualize the distinction on that old machine than some of our more modern ones. But then that tape reel, as these things would spin, it moved back and forth to different pieces of a different segment of tape, obviously with different data
That's
on
a
it.
weird question. What determines the rate of the spindles and how they turn? Like, are they different based on size or? Yeah.
Like how fast it would roll past?
Yeah.
There was just a fine control over motor.
Okay.
DC motor is basically a generator backwards. We bring in current and inside of a long tube, there's some magnets. So that as the current comes on and off, it causes those magnets to spin. So like a bunch of magnets going around in a circle. And when current comes on and off, those spin, and then we just have an axis connected to it that turns as those magnets spin. Which is the exact opposite.
It's at the rate of the length of the filings.
What's that?
I mean, and it spins with each filing to determine the 1 or the 0, or the north or the south.
Oh, that's how it was spaced out on the tape. So every bit was evenly spaced.
Okay, so it's got an even rate.
Yes.
Okay.
Yes. Because then to read it, there's 2 types of heads, and this is what determines that spacing. There'd be a read head and a write head, which are basically the same size, and each bit is the same width as that read or write head. Sorry, I misunderstood what you were asking there, Tyler.
Yeah, no. I like that you went deeper into it, but you figured it out, and yeah, thank you. That's awesome. Okay.
Right. Yeah, and then these two heads, when we read data, there's a magnet sitting on a spring. That doesn't look like a very good spring. Let me exaggerate that in the picture. There's a magnet sitting on a spring so that as the different polarities would go past it, north or south, it would cause that magnet to bounce up and down. And then from that bouncing up and down, that's where we read that. This is back in the days of the vacuum tubes and like heating coils, even some in electronic stuff afterwards. I guess computers and James Bond movies, the old James Bond movies always look like this. The great big machines back in the 60s.
A mainframe.
Mm-hmm. Yes, whereas the right head would be held stiff, so that as the tape rolled past that, the polarity on the right head would change what's on the tape. Is how those would work. And this is the important distinction, because the tape itself is holding the data along with some other parts, right? It's going to have some other metadata about it. So a start point, an end point, timestamps, things like that. But when we read and write the file, that's just a small segment of it. And the overall thing makes it into the file. So that's the distinction. Has to do with like what we actually work with when we read and write the data isn't the file itself. It's kind of the thing that can see the file, see the data. In particular, that's the read and write heads only look at that internal part and ignore all that metadata in the background. And that's why
is that kind of reflected in common file systems too? It's like it's built off that.
I only heard half that question, but I think so.
Oh,
but,
I'm sorry. So is that
file system is still like that?
Yeah, it inspired. Yeah, it inspired modern file systems, and it's still in that.
Yes,
based on the physical. Yeah,
and that's the distinction I wanted to express, because when we write a program and store our data or open it back up, we only have this part. But for those of you all heading down like server administration paths or network infrastructure where you need to send files, or cybersecurity people are going to be much more concerned about that background metadata that we can't see from our read write part. The term we use for that's going to be handler. We work with a file handler, and the handler is essentially like those old read and write heads. That's the things that can see our data. They aren't the data themselves, right? That's a physical component. So as soon as it sees a 1, it sends the 1 down the line.
I have a question.
If it sees a 0, it sends the 0 down the line.
I have a question. What's important for cybersecurity people to recognize within files, or
so that's going to get into your cyber classes. For our class, we're just going to look at the files and stuff, and that depends on that's unique to every file.
Okay.
So that one's getting into very, very deep. That question's getting very detailed into cybersecurity, because it's going to be, the answer would be different for every file. It kind of depends on the file. I can say one of the big things that you would want that we can't read from when we just store the data is when was the last time that file was modified, or how much metadata is in the background, right? So like if you know somebody breached your security at 1:30 in the middle of the night, looking for files that were modified at 1:30 in the middle of the night is going to be a very important part. So kind of unique, but with handlers, it's like these physical devices. They aren't the data. The data is on the tape, and they can't do anything with the data one bit at a time. As it sees a one, it sends a 1, or If the RAM wants to write a 0, it sends a 0 down there. So it's like the piece that can see the file is what we work with when writing data. And that's what our actual lesson is, but I'm going to take it a step further and look at the tool the rest of y'all will need to work with that stuff. Reading and writing data is really easy. We saw it briefly in Raptor, right? So yeah, so that's just an intro, and that's kind of a long talk about that distinction, because usually that distinction is ignored in textbooks and things, and they just say they refer to file handlers as files, but they are something different. Sometimes that distinction is important, and it's like a 50-50 split. So I always like to make a big deal about it in class, because 50-50 doesn't quite seem like the right cutoff part for to ignore something to me. But so hopefully those wanting to follow along we're able to get Python installed there. And we'll want to, with that installation of Python, there's a simple IDE, sort of the default place to write your Python code and test your Python code. And that's called idle. If you're on a Windows machine, you just search for it, or anybody's on a Chromebook, it'll install there. If you're on a Mac, it would be under Launchpad. It puts it under Launchpad. But if you're like most Mac users, you're going to go into Finder, and in Finder under Applications, there'll be a Python folder, and it's in the Python folder. Or if you're on a Mac, just push Command Space and search for it. Spotlight's a really, really great feature. Find anything really quickly with Spotlight. And it's pushing your 2 thumbs down, so it's the easiest key press on the keyboard. So I think that's what the people at Apple intended folks to do. But somewhere you'll, with that installation of Python, you should see the idle shell, IDLE. So if you start that, so the shell is where we run the code. And if you go up to File and New File, then we get a little text editor to write the Python code and save the code. So I'm going to make a quick example here of some data, a payroll calculator, just a really quick one. That way we put it in there. We've seen payroll calculators or have the basic idea, right? We need to get the employee's name. So name is input, enter the employee name. Then we need to get the rate of pay. Rate is going to be input, enter the employee rate of pay. And hours worked is the last part we need for that calculation. Enter the number of hours worked. And not all of those are strings. I think I've mentioned this before. When I'm writing code, I like to put it together in the order my mind thinks about it in, but that often involves some jumping around because I don't think about it in the same order the computer needs it to processing. And so anything on the input is going to be in a string. That'll be fine for name, but rate's a floating point number. So that's money. So we need to turn that into a floating point number. If somebody works an hour and 15 minutes, they probably expect to be paid for that 15 minutes, right? And when it rounded down to the nearest hour when we get our paycheck. Then we can do our calculation. Gross pay is going to be the rate of pay times hours, and maybe a selection structure. We might as well do a selection structure. It's really easy, right? So if hours are less than or equal to 40, then that's our calculation. But if our hours are more than 40, then our gross pay is going to be a little bit more. Gross pay is going to be 40 the first 40 hours times that rate of pay plus 1.5 times the rate of pay for whatever's left. So times hours minus 40. So however many hours we are past 40, we get 1.5 times our rate of pay plus the regular rate for the first 40 hours. We're Americans, so I assume most everybody's familiar with that calculation. But that seems a nice simple example to kind of start in and show the need for persistent data. So maybe we have 3 employees at our thing. Those names I keep making up. I'll say Bob, Sally, and Becky. They make a certain amount of money and they're going to want their paycheck every week, right? So we have our little payroll calculator. So we have this, so we need to save the file somewhere. One important thing I'll note here, when you first install idle and you go to save files here in our, you use the local text editor for it and go to save things, where it tries to default and save them is where it installed Python, which is a very useful thing to know. Probably not where we want to save this file, but there will be times where we want to know where the computer installed Python. So that's an easy way to grab the installation path. I'm going to come over to the delete folder. I'll just call this payroll. That seems like a good name. And .py is the extension. It'll automatically add .py and idle. But that gives us a little calculator. So when we run it, we also have the idle shell, which is where it actually runs. And some debugging tools to help us track down problems. We can put breakpoints, see all this stuff. Actually, I'm going to go ahead and turn those on in order to do this. Open Stack Viewer, and I'm going to put an error message on. So instead of print this first time, I'm going to show you one of these features, and I'll spell print wrong. Let's see. Name made. Oh, whoops. Y'all don't know how to do that. We'll take whatever's stored in the name of the employee plus made cast as a string their gross pay this week. I'll put that nicely in a sentence. So get an output. I did leave an error in here because I want to show something useful for the debugging tools. Okay, open Stack Viewer. If I go and run this, well, there's an error. Debugger's on, so it loaded in the file. It renamed it to main. That'll be important for those continuing on to path later. The file we actually hit run on gets renamed. So go to the next one. Gonna do some stuff. Looks like a bunch of setup stuff. There we go. We finally get up to our starting point. Enter a name so we can type in a name. So one of the employees was Bob. Then have it set to run. I probably should have put that error near the beginning. That way we would eventually hit it. I'll put plaint instead of print. And that way the error happens at the beginning instead of the end of the program, because I just want to show that. And then, so turn the debugger on. What? You can only talk to the debugger. Oh, okay. Oh, And there's no clear button here. A question came up earlier about clearing this. If you close your shell and then run your program, it will restart that. Okay, so here's the thing I was wanting to look at. This is all the code we wrote, right? Just a couple of lines. It's not much there. And this little window that popped up here, this is a stack viewer. This is how much code is actually, this is all of the code running on this program. I'll start expanding things. You'll see folder after folder after folder after folder. And digging through folders, we finally got to way down to one thing there, a Python script. You'll see all of this stuff is running as we're doing this. So here's our script. It gets renamed when we actually run it. But all of these other things are getting ran as well. I've only expanded a couple folders, and you can see there's a whole lot of stuff involved. So that's something that a lot of people might not realize at first. Python makes everything easier to type in, but there's all that other stuff in the background. And all that other stuff in the background is what makes Python considerably slower than all of our other programming languages. Usually we take control of that stuff, which makes it a little harder to type our code, but it runs a lot faster. But eventually, yeah, now getting back to this example, we have this payroll calculator. We've got an employee named Bob. Maybe Bob makes $22 an hour and work 37 hours. We got his thing. Then we'll go run it again for our next employee. Got an employee named Sally who makes 31 an hour and work 39 hours. Get the amount of money she made this week, and so on and so forth. And well, it works, gives us the calculation, but come the following week, we got to run payroll again, right? Well, when we run it, first two things it's going to ask are the employee's name and their rate of pay, but names don't generally change. And right, it's a big deal to change a name. Some of the ladies in the class that have gone through that in marriage know that it takes a special trip to the courthouse and a bunch of documents have to be refiled, and there's a big ordeal changing your name and getting a name changed. So that data hasn't changed since last week, and raises most jobs it's once a year, right? One raise a year, sometimes maybe two or something, but raises, that data is not going to change very often. So definitely a situation, what changes is the number of hours worked. That's different every time. But that other stuff, it would be much better to keep that around. So that's where persistent data comes in. And sort of our topic for this week, we looked at it in Raptor a little while ago, 2 weeks ago, I think, because it's something some of y'all are going to want for your projects. But basically the same process applies for Python. We open a file handler, something that can see a file, and then we use that file handler to pass data into the file. And our instructions are for doing that are really easy. I'm going to move some of this into functions. So I'll create a function here called get employee data. And I'll start this with a prompt. Choice is input, is there a new employee? because that's the only time this would change, right? So we'll ask, is there a new employee? And then we can just check on that. If choice is equal to
Sorry
yes.
to be the grammar police here, but you spelled the there wrong.
Oh. Is that, yeah, that one.
Sorry if I.
Oh, it's all right. Yeah, there's the computer doesn't know how to spell, so, but that is an important one. I should probably capitalize this as well, because an important rule when developing software is never, ever, ever output a grammatical error. Because grammatical errors, even small ones, will make your program look buggy quicker than a program that's full of bugs and crashes constantly. People will notice it. It shows up. It's something drilled into our head. So if there's a new employee, then we need to do this stuff. I'll indent that to the right spot. Otherwise, we'll just move on. So I'll create a so first thing we're going to do is call that method. We'll call get employee data, ask if there's any new data to put in. If not, then we'll just move through and work through our hours and do our calculation probably a number of times. It's quite likely that it's going to be the same employees every time, right? Like maybe we have 3 employees. So whenever we do get a new employee, what we want to do is probably save that to a text file, some sort of file, so that we can keep it around, access it, and do stuff with it, so we don't have to ask every single time. So if there's an is this a good way to do it? I think this example might have gotten kind of complicated here, more complicated than I was thinking, because I was just making this up as I went along and might need a few steps. But I'm just going to write a file of employee data. Oh, actually, I'm going to change this. Let's just have a file of employee data that we use. So for that, we will need some sort of file. I'll make another one that does this. Oh, I thought I copied and pasted those. Name is input, enter employee name. And rate is input, enter employee rate of pay. I'm just going to come over to the side and do this. And then once we have that data, we can just write it to a file. And our keyword to do that is just open. And it's a little bit of predictive text here. The predictive text in idle is not really super helpful, but sometimes this is enough to show us this part. So the first thing it asks is, what file do we want to open? I'm just going to make a little temporary database for us, not a fancy database, just a sequential text file. And that means just human readable text code in a file where the order matters. We can keep track of our data because we know what order it was written to the file in. I'll call it employees.txt. We'll put all our data there. And the next thing we need is the mode we're going to write it in or read it. So our options there are either W for write, R for read, or A for append. If we do W, that's actually an overwrite. So that will replace whatever's in the file. If we do an A for append, then it just goes to the end of the file and adds another line at the end. So I'm just going to do an A for append. That will create us a file handler. There's actually a proper way to do this that our book did not use. So I'm going to go with what our textbook used. And that gives us a file handler, the thing that can see our file. So we'll want to put that somewhere. I'll just call it handler. So we have this file handler that can see this file and write the data to it. And then that's our keywords. Handler.write, and we can write the name of the file. But in order to keep things organized, we probably want one data point on each line. So after we write the name, we want to add in a line feed. So concatenate \n, that means go to the next line. It's mostly what we think about when we hit the enter key, right? When we hit the enter key, we go to the next line, but the enter key has lots of uses, right? So it's not the entire enter key, but that's one of the things the enter key does is go to the next line. So write the name of that file, the name of the employee, then do a line feed. Then our handler will write the rate of pay plus a line feed. And notice here that I did not do any casting. Does anybody know why? Anybody have any thoughts on why I just skipped that?
You're not assigning anything, you're just telling it to do something.
Yeah, we're not doing any math with it because rate of pay is still a number, but we're not going to do any math with it. We're taking it from the keyboard and then sending it to a text file. So if we turned it into a number like we normally would, we'd have to turn it back into text when we send it to the file. So whenever you do those, whenever you get data, you always want to pause and think about what you're going to do with that data before doing some other stuff. And then in a really important part, I'll demonstrate here, just I'll go over the side, yeah. So I got a couple different things going on here. There's one last thing I need to do for the file. I have to close it, but y'all notice the problem? My cursor was over in the other file. I think everybody's probably experienced that at some point, right? Our focus isn't where we thought it was, which isn't really a problem for humans. We're intelligent. We'll notice that the text isn't showing up where we expected it to and adjust very quickly, but a computer will never notice that. So if we were to leave this file open, anything we do afterwards, the computer is going to keep working in that file, which could be very disastrous because the computer's never going to know. The computer's not going to pay any attention that it's working in the wrong spot. So it's very important to close our file after we finish writing it. So that's our steps. Same thing we saw in Raptor when we looked at it with the flowcharts. There, our keyword was redirect output or redirect input. We'll use open to get a handler, and then write sends out. That handler has lots of parts to it, one of those being write stuff. So we can do handler.write to send stuff to the file. And then obviously there's a .read to get it back. We'll see that here in just a moment. And then when we're done, you want to make sure you close the file. So if I run this, then we can collect all of our employee data all at once and not have to ask for it every single time because, well, the employees' names aren't going to change and they're only going to get a raise once a year or so. So we don't have to re-enter the rate of pay every time, because that's just an extra spot where a typo could happen. Oh, have to save first. I'll call this new employee script. Give it a nice distinctive name to keep track of it. And the type is Python file, so it'll add a .py extension. Okay, so now we have an employee named Bob who makes $22.22 an hour. And notice how this will be important for the stuff after the break. Notice how all I put here was the name of the file. That file didn't exist beforehand. Actually, I probably could have looked at that and shown that.
Yeah, I was wondering that. Do you create it, or does it automatically create it? Or like
it does automatically create it. So I'll delete it from here. I probably should have showed that the first time. And then you can come up here and hit run, or F5 will run it. And F5 is fairly consistent as far as the run button for most of our IDEs. There's obviously not an official standard for that, but consistency is nice. So whenever programmers make new IDEs, they usually try to put it to F5 unless they have a better thing to do there. So if we push the F5 key, is a quick way to run the program. So we just deleted that file. It doesn't exist. So write Bob, and Bob makes $22.22 an hour. Got to the end of the program. If I come back over to File Explorer, you'll see it was recreated a couple of seconds ago. If we look at the date modified, a text file, 1 kilobyte. So there must be something in there. And so there's our data about Bob. And we can keep track of this because of the order things go in. So they're called sequential text files. We keep track of our data based off how things are loaded in instead of that. Actually, I'm going to write this a little bit differently and show another useful thing for an array. So instead of separate lines, I'm going to put both of Bob's things on the same file. So let me close that. There's no clear button on the Python shell. So if you want to clear it, you can close that. And then when we run it, it'll create a new one. So I'm going to delete that. And I'm going to put them, instead of that in there, I'm just going to put a comma between them. Which means I can probably move this up here. Plus that stuff. And y'all have probably noticed this by now, right? Little changes happen as we start putting code together. We come up with better ideas and edit it, little things like that. So now I'll put the name.
Why is it not a float input on rate? I'm sorry for interrupting.
Oh, it's all right.
Why is rate not a float input anymore?
Oh, because we're not going to do any math with it.
Oh, okay. Yeah, I forgot. Sorry. I was debugging mine. I'm like,
because it could turn into a float, but then when we write it, it has to be text, right? So we'd have to turn it right back into a string.
Right, what we were talking about earlier.
Yes.
Okay. Thank you.
And it is perfectly okay to do that. The machine won't ever complain, no matter how many times we do it. It's actually probably better form to go ahead and do that. Make sure we're working with the right type of data every time. And if our name is a string, but it won't hurt again any way to cast it, it might, a lot of times it's just a better idea to go ahead and do that anyway to make sure it's safe. So I'll put them on the same line and then we can read it back and just split up that data when we read it back. So open the file handler, use that handler, which is kind of like the read write heads in that picture. In this case, the right head is the one on the that's held stiff. So when the tape rolls past it, it would change the polarity of the little magnets stuck between those pieces of plastic. And then close the file when we're done. And if it doesn't exist, it will create it. W will delete what's there and write new stuff. And A for append will go to the end of the file and add some more stuff.
That makes sense. Kind of like when you're determining in command line if you want to do this or that with a letter.
Yes.
Trying to, yeah.
So when we enter is ready to pay now, the file didn't exist, so it should have just added, it created it and added that
Could you
in
share
there.
those text files with us?
What's that?
Could you share those text files with us that you demonstrated here today?
Oh, yes. Yeah, I'll share these. It's often good to follow along though. I was going kind of slow, hoping you all are following along with Python stuff, but I will share them. So we can add more employees. If I can figure out which file it is. Oh, this one. Run that again. Got another employee, Sally, and Sally makes 3131. And from over here, F5 to run that again. Maybe a Becky. These do not represent any people. I'm just making names up. 2112. That seems like a good number. Maybe one more. Run that. David makes
3030.
3030. That's a good number. Easy one to type in. So that'll work. And now, if we go over to the text file, you can see each one of those, every time we ran it, it was in append mode. The file already existed. So then all it did was open it. It'll try to open it. And if it doesn't exist, it'll create it. And then added those numbers in. So now we can read those back into our other script and get some of this stuff out of the way. What is that? I keep trying to go to the left. I guess I was working on the Mac all morning and I got used to the minimize button being on the left instead of the right. So now where we had those inputs earlier, which I deleted them. I always warn people against doing that. It's always a bad idea to delete things immediately. Let me go back to where I deleted those. Well, before I got distracted, because I was just kind of making this up. So I need these back at the beginning because they're not inside of a method now. Let's go back to our original one. And whenever something's working, which this did work earlier, it's always a bad idea to delete stuff as you make changes. What's a much better idea is to comment it out. So if we look at under edit, maybe it's not under edit. Under format, to comment out a bunch of lines, we can push Alt-3 or Alt-4 to uncomment them. So if I select both those lines and push Alt-3, it'll comment them out. And then if the next thing we're going to try to do doesn't work right, we can still get back to the last thing that worked. And then if it does work, then we can delete those lines. It's just always a good idea to never delete stuff until you're certain that you won't be coming back to it. So comment things out and then try the next thing. And if the next thing doesn't work, then you go back to where you were, the last thing that worked. But if the next thing does work, then you can delete the files when you know you won't need them anymore. That's right. Delete the lines when you know you won't need them anymore. So instead of doing that, let's read our file. Whoops. There was that cursor in the wrong place thing. I bumped the touchpad on the laptop, put the cursor somewhere else, and then when I went to do something, the wrong thing happened. So that very important aspect of make sure we can make sure our cursor is in the right spot, but the computer won't. So always remember to close your files. So we'll open the same file. All of our data is over here in employees.txt. So I'll open up employees.txt. And this time we want our mode to be read because we want to bring that data in. So it's like creating the other head on that little picture I drew earlier. Instead of a right head, we want a read head this time. And there's a bunch of lines, which in a given situation, we might not know how many lines are in that file, right? We know in this case because we just wrote them there, but over time, that file might get bigger and smaller, and any particular run, we might not know exactly how many is in there. So normally we'll use a for loop for that, which in Python, when we write the keyword for, it's actually equivalent to what we would call a for each loop in other languages. So when we say for, it's really for each of something. In this case, so for each line in handler. So every line of text that handler can see. That's a natural place to split up the file. So that's what it'll try to do first. It'll split it up into different lines, read them in one at a time, and then we can read in that line. And there's going to be a bunch of stuff. So I'm going to come up here and create an array to put all of our employee data when we get it back in. I'll create an employees array, just an empty one. And then we'll call, then we'll append that. So we do have to actually read the file, read the line. So the handler is only looking at it. It's like, okay, there's a line there, but it's not going to actually read it until we tell it to. And when we do, we'll pin that onto that employees list. There's one other thing I want to do though. Actually, before appending that, I'm just going to run this and print this stuff out. Yeah, I'll print whatever line that handler is looking at, and then so we don't get errors, I'll comment this stuff out. Alt-3, and we'll come back to that. So we'll open up that file for reading, kind of loop through, and then we'll print out whatever we see in that file. So if we save that and run it. So there's the things we can see. See Sally. Wait, isn't one missing here? I'm gonna read the first one. Oh, I think I need this. Nope. Oh, I was doing this in another language earlier. So stuff is going to be handler.read. Oh, this will work better. Um, I'll do that. Okay, so we'll get to the loop in a second. So we'll open up that file and then call handler.readLine. It should give us the first one. Oh, whoops. And print that so we can see the result of it. That was just a silly mistake. There we go. So there we got our first line. And we need a way to walk through every line in that file. So that's what the loop is. So for line in handler, so every line that it can see will loop through. Oh, save it. Notice how it's skipping ahead at times. Something seems a little off. But print line, kind of look at some of the errors. So that worked. Notice how it's automatically reading it basically. When you look at the instructions in the book, they're going to show that read every time and all of that, or need to call handler.read. That's what they show in the example, but like we just saw here, that seems to miss some stuff in the file. Also, it did something completely different up here. Neither one even has our total one. So whenever we do a for loop, so it's like for each line in handlers that the file handler can see. So we already have, it's set to read mode. So we're already going to have the line. So we want to we want to print the line. Actually, I want to do more stuff than that, but that'll show us each particular line. I'm going to take that a little bit further. I'm going to add this thing on the end because it's a line of text that's a string, which means there's some built-in things we can do with it. One of those is strip, which will remove any white space. So I run that. Oh, save it. You can see we got rid of that extra space around it. But we also have two pieces of data on each line. So we probably want to split that up. So after we strip that text, we can say dot split. And we want to split it every time it sees a comma. Can I zoom in? I should probably make the font bigger. There we go. That's probably better for the class example. So we'll get a line, and our textbook didn't make it very clear about that. They were just saying call the handler dot read every time. But then when you get to the assignments, they're going to want you to do something more like this, and repeatedly calling handlers a problem, because this will automatically read the next line of text and put that in a variable called line. And then we can get that line, remove any excess white space like that line break at the end, because we don't need that in our code. That's for the file. And then split, this one will take our string, and every time it sees a comma, it'll basically cut that string in half and put each piece of it into an array. So when we do it this way, we get back an array. Oh, I have to say. So you can see now we have an array that we can ask for those indexes in 0 and 1. 0 has the name, 1 has the thing. So now we're in a better spot to do this calculation. Alt 4. Yeah. So I'm not going to do this. So once we get that, I'll put it in a variable called imp, which we just saw as an array. Oh, might as well spell that out. Don't need to abbreviate here. We'll have something called employee, and then employee index 0 is our name. So we'll stick that in a variable called name, and our rate of pay is that employee array we just got back from the file index 1. And then we can do all this stuff. Then we'll ask for the how many hours are worked. And if it's under 40 hours, they get their regular pay. Otherwise, they'll get their full rate of pay. And then we'll print out what they did, what they made. Does that code make sense? So some of the stuff we talked about earlier, so it's just in a different spot there at the end. So now, instead of asking the user every time for it, we're just going to go read that stuff from a file. And then we'll loop through, and all we have to ask is how many hours did they work? Oh. This is that one we better, I probably should have asked about that. We've talked about casting them a couple times today already, right? Our rate of pay is a number, so we better make sure that's a number when we get it back, so we can do math with it.
Yeah, good idea on that.
Any questions about that? Uh-oh. Is that still, let me quit opening that. Oh, a typo. Employee is not defined. And you all are learning Python at a good time. If you just downloaded Python 3.10, one of the big issues they improved in Python 3.10 is the error messages are better. They improved all the error messages. So when there's something like a typo, it looks through the variables, it looks through all of your variables and function names and things like that, and tries to figure out which one you were typing. So our error messages have improved in 3.10 from what they used to be. Let me run that again and talk about error messages. So a name error, that means something's spelled wrong. And you'll see a line number in these messages. So it crashed on line 13, which we don't have line numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it crashed on this line. So all we really know for certain is it did not happen down here, because it didn't happen after the crash. Whenever you hit something like that, you go to where it crashed at and then work backwards till you find it. In our case, it was right on that line. There's just a typo there. But go to the line where the error message points you, and then just start working backwards through your code until you find where the actual problem was. Because computers aren't intelligent. All they can tell us is where they stopped working. They can tell you if the actual problem was 5 or 6 lines earlier. They can't tell us that. Oh, not sure who that's referring to, so we should probably improve that message a little. Oh, and you can always crash your Python shell, so if things get stuck, just close it. Like if you accidentally do an infinite loop or something. So in our prompt here, enter the number of hours somebody worked. So I'm going to come out of that string and concatenate in something else, the name. So I'll add a name, and probably want some spacing around it. So that we know whose hours we're entering. I guess that's about the only thing that needs change from that original version. So how many hours did Bob work? So Bob worked 32 hours, then we get his pay. And then jumps right to the next one. Enter the number of hours Sally worked. So Sally worked 43 hours. Get her rate of pay. How many hours did Becky work? Becky worked 26. Maybe she had to take a day off. And David worked 37 hours this week. Then we hit the end of the program, and we didn't have to enter our data again, our data that needs to be persistent, the name and the rate of the pay. We just have to enter that one thing that's changed. So in the following week, we open up the software, run it again, and same employees, so we don't have to re-enter their data. How many hours did she work? She worked 41, and she worked maybe 46 hours, making up for that time she took off last week. And this guy worked 39 hours. So there's the benefits in writing files. That's our actual, goes with our assignments, the learning objectives. That's what we want to make sure we're able to do. And I'm pretty sure most of y'all need to do that in your final projects, is keep data around, or even things not in class, right? If you're making your own little projects to get practice or things you think will be useful, you're probably going to want to keep data around. And the easiest way to do that is through a sequential file. We can open a file handler for either A or W to write stuff, and W will erase what's in the file and replace it, and an A for append will just add stuff onto the end. Write your data to the file and pay attention to the order you write it to the file in, so that when you read it back, you put it in, read it in the same order. And then close your file, which actually I don't think I closed this one, did I? Oh, yeah. Then after we're done with everything, then close the file. We're able to get away with it here because you'll notice that close is the very last thing. So when we got to that point, the script stopped, and then it would have closed the file automatically anyway. But if we have more code that we need to do afterwards, which we usually do, then we start hitting problems. And when we read it back, the same thing, just open it for read mode. And one important thing to note before we take a break is we just passed in a name for that file. So with just a name, here's the actual files. If we just have the name, where's that? Oh, these two. If all we do is enter a name, it will put it in the same folder. If you want to put it somewhere else, you have to put the entire path to where it goes. But for most of the stuff in this class, put it in the same file will be enough. So that's the basic idea of file handlers. Let me attach that to the chat room. Oh, yes, save that. Close that one. And chat.
I have a question about my code. It looks right, it matches yours, but I'm still getting a bug, and I don't know if it's just in Spider or if I've even retyped the line. I'll show you.
Share your screen with me.
video.
So I just put those files into the chat room.
I'm on my phone to do this. I'm sorry. I know that's not the best.
Let's see if I can make that bigger.
Yeah.
Speaker. Handler is open. If you hover over it, what's the error say? Over the little red dot.
valid syntax, then if I go here, yeah, how it gives you a little, after a second at least,
I think you might have an indentation error.
tries to give you a little guide. Yeah, look, here's the total. 444 if else print.
I don't see an error. Make sure the indentation's right. So put your
Yeah,
cursor
right.
at the beginning and hit backspace to
Mhm.
go to the previous line. And then hit enter once and let the
Okay.
IDE handle that.
Oh, well, okay. Never, I accidentally hit arithmetic error print. Okay. Funny.
Okay, the video froze up. I can't quite see what you're doing, but
Oh, okay. Yeah, I'll
did you figure out what it was, Tyler?
I have not, but it's it was causing more problems trying to do it that way. I'll send you the code and maybe you can help me out then too.
Okay, yeah,
Excellent.
well, let's take a look at it, but it's been a moment, so it's probably a good time for a break, right?
For sure.
Does 10 minutes sound good to everybody or anybody? So the clock says 2:30, so we will get back to this at 2:40. And that's the part for our requirements. And then after the break, we will go a little bit further with something that will be quite useful for a lot of y'all. I'm gonna go get a cup of coffee. I will see you in just a moment.
All right, I'll see you.